Alright class, welcome, Math 2015 students, to today's video. And on today's video we're going to do some more work with learning outcome number 2, thinking about equations and solving them like an elementary student would, reasoning about them in their whole entirety. Okay, so this is going to be a little bit different style, but it'll help us, what you learned in Math 2010 will help you be able to solve these homework questions. So what I'm going to do is I'm going to explain a few explain a few examples, and then you can use these to do your homework. Hopefully it'll help them go easier. Okay, so the first thing that we're going to do, once we are in Math 2015, we're in Unit 1. We're doing learning outcome number 2, homework hints, I'll call it. Okay, so part 1, I'm going to solve by reasoning, solve for x. Let me put that down too. Solve for x by reasoning about the equation in its entirety. Okay, so for my first example is going to be x plus x plus x equals 21. Okay, so there's a couple ways that we're going to do this. So way number 1, I'm going to separate 21 into 3 numbers. Three numbers added together that are the same. Okay, so we're going to do, so from that first part we have this next equation, and on this homework we want to do a stack of equations, a series of equations. So I need to think about what number I can add 3 times to get to 21, and that number will be 7. Okay. So if we have 3 numbers added together make 21, or 3 numbers added together make another 3 numbers added together that are the same, then we can deduce that one case for this, like x, is going to be one case for that 7, because they're all the same x's here, they're all the same number here. Okay. Way number 2, we can combine the 3 x's into 3x, then factor our 21 into 3 times some number. Okay. And so since I'm using x as my variable, I'm going to use the dot notation for multiplication. So we have the 3 x's will start out here. Those 3 x's there now become these 3 x's here. Okay. And so we have 3 times the number x is the same as 3 times the number for 21. We know that that number is 7. Okay, so since I have 3 times something and 3 times something, this right here represents 3 groups of x. And this right here represents 3 groups of 7. Okay, so if I want to know what x is, what number that is, then if I have 3 groups of that number and 3 groups of 7, we can deduce that x is going to be equal to 7. So that was my first example. Example number 2. 4 plus 5x equals 20 plus x. Okay, reasoning about this equation in its entirety. Now I have 20 on this side here, and I have 4 on this side. And so it's easier to separate your 20 into 4 plus something until you can get rid of the 4s. Okay. So I'm going to copy this part down. 4 plus 16 makes 20. Okay. And then I can go ahead and cancel off things from the sides here. So the 4s can cancel here. And what I'll have is I'll have 5x equals 16 plus x. Okay. So I cancel the 4s. It's like I'm taking the 4s off of the 4, like maybe 4 blocks or something, 4 unit cubes, off of a pan balance from both sides. Okay. So this is one side of the pan balance, and this is the other side of the pan balance. And so if I take the 4 off of there, it'll maintain the pan balance as equal. They'll stay the same. Now I have 16 or 5x equals 16 plus x. I'm going to separate out my 5x into 5x's added together. So I have 5 times x, which is 5 groups of x. And I can copy 16 plus x down. Again, I have another pan balance. Okay, I'm going to take off x from this side and this side. And think of it as a pan balance. We need to maintain balance. So we have to separate our numbers the way they're expressed into forms that we can just take off the same thing from both sides. That's the goal for this lesson, and that's likely the way the elementary students will be thinking about this. Okay. Now I have, I'm going to rewrite this down. I have x plus x plus x plus x, or 4x's, equals 16. So I'm going to need to separate 16 into 4 numbers that add themselves together. And that happens to be 4. That happens to be the same number because I'm looking for x's. Okay. And so if I have 4x's equal to 4 sets of 4, then I know that x is going to be equal to 4, just one of those. Example number 3. 45 divided by 9 is equal to x plus 4. So when I want to find out what x is, isolate it, get by itself, I have a number added to x, and I have this division on that side. So I need to get one number equals x plus that 4. So that way I can separate the number into 4 plus something. So 45 divided by 9 happens to be is 5 equals x plus 4. And I need to separate my 5 into something so I can compare it with my 4. Well, 5 is the same as 4 plus 1 equals x plus 4. And like a pan balance again, I'm going to go ahead and cancel off these 4's here. And I have that 1 is equal to x. Okay, so that one's a bit shorter. Example number 4. 14 times 70 is equal to 140 times x. Okay, so this one can be done in a couple of ways. Way number 1, I'm going to, I have x with 140, so I can eliminate this and 14 times 70. So I can eliminate the 70. Okay, because that one... No, I can eliminate the 70 from using the 140. Okay, eliminate the 70 using the 140. So we're going to go ahead and do that. So 14 times 70 is equal to 70 times 2 times x. Okay, so I'm going to split up my 140 into 70 times 2, factor it. Okay, and then that's something times 70, and that's 70 there. And those will cancel. And we have 14 equals 2x. So we think about two numbers. 14 is equal to x plus x. Two numbers that add together themselves that are the same is 7 and 7 equals x plus x. And I only need one case of those, so 7 is equal to x. Okay, here's way number 2. I can eliminate the 14 using my 140. Okay, this is how it will work here. So I'm going to start with this equation and separate my 140. I'm going to factor it into 14 times something. Now my 14s will simplify here. We brought off that balance, and 70 is going to equal to 10x. So I need 10 numbers, because I want to have 10x's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10x is there, and I need that equal to split up. I need to split up my 70 into 10 numbers that add together that are the same as well, and those happen to be 7. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a bit tedious, and so that's why algebra helps us. But when the numbers are small, like in way number 1, then it goes a little bit easier. And because I have 10 7s equal to 10 x's, then each one of those x's must be equal to 7. Okay. Example number 5. If x minus 17 is equal to 14, then x minus 16 is equal to what? So let's go ahead and compare sides. And the difference between the sides, using the equation in its entirety, is that that's 17 and that's 16. So they're both being subtracted from x. Okay, so that's good. And I need to just convert my 17 here into something with 16. Okay. So I know that this relationship between 16 and 17 is that x minus 16 plus 1 is going to be the relationship I need. So I set that equal to 14. Now x is trying to be, and these two numbers, 16 and 1, are being subtracted from x, both of them together. And so we call this distributing the negative, but really I'm trying to subtract 16 and 1 from x. Okay. So I can simplify it by removing the parentheses and putting minus 16 and minus 1, because both of them are being subtracted from x. That whole quantity there. The whole quantity is being subtracted. Now I can see go out as separate parts if I take off the parentheses. So that's why that positive becomes a negative. Okay. So we have a minus 1 here with the 16. So we want to get just x minus 16 by itself. Okay, so we have minus 16 minus 1, and I need to do something with that. Subtract 1. So I need to put 15 minus 1, convert my 14 into 15 minus 1. And when I do that, I can go ahead and take off the negative 1 pieces, and then do x minus 16 equals 15, which is my answer. That's what I wanted x minus 16 to be. Okay, so I'm not looking for a number, I'm just looking for what the quantity is here. X minus 16. Let's say that you're going through these and you want to just double check to make sure you're right. Okay, so on this problem, we have x minus 17 up here. That equals 14. Well, if we want to know what a number subtract 17 is 14, we can just deduce that x is going to be 31. Okay, because 31 minus 17 is 14. So this is my check in yellow. X has to be 31. So 31 subtract 17 is equal to 14. Well, it wants us to know what x minus 16 is. So we know x is 31, so 31 minus 16 is actually equal to 15. Okay, and so that checks right here and right here. So this kind of check you can do, we take your answer and just substitute it back into the original equation for the variable. Example number 6. 1 is equal to 21x. Okay. So how are we going to reason about this in its entirety? We need to get x by itself. Well, we do know that 21x's add together equal 1. Thus, just one of those is 1 over 21. Okay, because it's the definition of fractions. Unit fraction 1 over b is b copies of it make the whole. Okay, so if you remember from 2010. Okay, so that means that we can deduce that x is equal to 1/21. Example number 7. 25 is equal to decimal 0.2 x, or 2/10 x. Okay, we want to be able to reason about this equation in its entirety. What's going on with the x, and what will happen to the 25 if we just get x by itself? Well, we know that the operation on the x, 0.2, is 1/5. Okay. If 1/5 of a number is 25, then 5 times 25 is that number. Therefore, we can say that x, that x is equal to 125. Okay, so 0.2 times 125 gives us 25. So for our check, 0.2 times 125 is equal to 25. Example number 8. Let's see. Okay, example number 8 starts our new section. So there's a few homework problems at the end where we want to explain whether the equation is true for all sum or no values of x. Okay. I'll make a note here. They don't explain this in the homework, but when you get to this problem in the homework, you need to do it this way. For this class, we will only consider values of x that are positive. We're going to stick with integers as much as we can, which means like we want to stay away from fractions. Okay, so I believe that the examples in the homework will work out okay for that. So now we can get to example number 8. We have the equation x times the quantity 2 plus 4 equals 2x plus 4x. Now, will this equation work for all some or no values of x? What we need to do is we need to explain with some reasoning here. This one, as you notice, is the distributive property, where I took my x and I multiplied the 2 and then the 4. Okay. The distributive property is a valid property for all parts of the property and for all values of x here. So this one works for all values of x. The equation is an example of the distributive property. The equation is an example of the distributive property. Okay. So that one will work. Example number 9. Six plus 4, 6x plus 4 equals 6x plus 5. Okay, so will that work? Well, what really stands out to me is that the 6x and the 6x can be pulled off the pan balance, and I'm thinking about whether or not 4 is equal to 5. Okay, and that will never work. Okay, so this does not work. For any values of x. The 6x's can be taken off or out of the equation, and we are trying to say 4 equals 5. Okay, which it never does. Okay, so that one does not work for any of them. Our last example, example number 10, has 2x plus 5 equal to 5x plus 2. That's kind of neat, isn't it? Okay. We're just switching the letters in the switching the numbers here around. Okay, so it looks like that it might be true for an x. It's not distributive property, so it won't always work. It's not like I'm trying to say an impossible equation. So let's go ahead and solve it for x and see what we got. Now 2x plus 5, and we have 5x plus 2. So I'm going to go ahead and take a look at the 5 and the 2 here. The x's, I can eliminate 2 of them from this side and this side. So to do that, I'm going to separate it out to x plus 5 equals x plus x plus x plus x plus x. So there's 5 x's there plus 2. Okay, by elimination, by taking these x's off the pan balance, you can eliminate 2 there and 2 here. And what do we have left in the pans, in the balances, is 5 is equal to x plus x plus x plus 2. Now I can take a look at the numbers. Okay. Before I could also take a look at the numbers too. I could compare my 5 and my 2 as well and work there. So either way will be fine. So my 5 and my 2. So I need to separate my 5 into 3 plus 2. And my x's I'll copy down, and the 2 there. So that the 2's can be eliminated from either side here. And I have 3 is equal to x plus x plus x. So what I need to do is I need to separate my 3 into 3 numbers that add together. And happens to be 1 plus 1 plus 1 plus x plus x plus x. And I need to do x is equal to 1. Okay, is my answer. There's 3 x's there, there's 3 1's. And that's all for the examples I have. So this should help you do the homework. The reading has a lot of good things about the students and their thinking. They do kind of go more traditional than I do in my reasoning. So if you do kind of things like what I've shown you in the video, you'll be fine. And you just don't want to go to strict algebra, traditional algebra rules that we have been studying. So we want to be more flexible with our approaches. Okay, so try to stay away from that, and you should be able to if you follow the directions in this video. I hope you guys have a great day.